Hi everyone, Nate Solves Problems here, back with another video. This is a continuation on my series on different coordinate systems. And this will be an extension upon what we did with looking at polar coordinates. If you haven't watched that video, check it out here. It will help you with a good foundation and what you need to know to apply it to cylindrical coordinates. And will really help you to take that next step further. When we're looking at cylindrical coordinates, we're not doing much more than we're doing in polar coordinates. We're just adding a third axis. We're adding a z-axis perpendicular to that xy plane. And if we think about a circle on the xy plane centered at the origin, and then we take that circle and we stretch it out, we pull it up through that z-axis, we'll get our cylinder. So what is the volume element now in cylindrical coordinates? And where does the volume of a cylinder come from? If you're looking at that formula, pi r squared h, a few things should come to mind. Pi r squared is the area of a circle multiplied by height. Keep that in mind. So we're going to derive this volume element. dv equals r dr, d theta dz, which part of it is just that dA from polar coordinates. And now we're taking that square and giving it a third dimension. We're giving it a height of dz. That should make sense. So it's not much further from polar coordinates. It's just now we have the z-axis to worry about. And now we're just expanding that circle to a third dimension. And let's say we have an infinite number of circles stacked on top of each other. That's how we'd get a cylinder. And so originally, starting with our dA of r dr d theta on that xy plane, we give it that height of dz. And that's how we're going to get that volume element. And if we sum them up, we would get the volume of a cylinder, pi r squared h, which if you want to, go through that triple integral and see if you can get the volume of a cylinder. And just think about trying to visualize it. Using that volume element, what are you doing? You'd get the area if you wanted to, or first a line, then you have the area with some thickness dz, and then you're summing up those disks all the way to the top of that cylinder, getting the volume of a cylinder. So some useful relations when looking at cylindrical coordinates are just the same ones you had in polar coordinates. Our z-value is our z-value, it's not going to change, and we can get the others by looking at the same relations as we did in polar coordinates. And the reason we use cylindrical coordinates is it helps you to think about then that those polar coordinates now in 3 dimensions. And it's going to be a good building block from when we take cylindrical coordinates and we take it to spherical coordinates, we use the other coordinate systems just to make problems easier for ourselves, just to think about that space in a different way. And we have our new volume element, which if we think about it, is just dA, the area element from polar coordinates, times dz. And that's a good way to think about cylindrical coordinates. It's just polar coordinates with a third dimension, that z dimension. Thank you. Look forward to my next video on spherical coordinates and others. Please let me know if you have any questions or what videos you would like to see. Thank you again for watching. Have a great day.